Hi to all my students. It's quite some time that we haven't meet up together. Today we're going to have a roughly 30 minutes YouTube video going through half of the chapter 3, function and graph. Before we start the actual content, you need to prepare yourself with 6 pieces of A4 paper. What should you write or draw inside these papers? Here, you're going to prepare the first paper. So you have the boxes drawn there, and then we come up with the title, tutorial 5.1, and then your student ID. Same goes to second piece of paper. You have the title tutorial 5.2 and then your student ID, tutorial 5.3, tutorial 5.4, tutorial 5.5, and the last one, tutorial 5.6. Pause this section first and create those 6 pieces of paper. By end of the class today, besides you're going to copy the question and then solve it yourself, at the same time you are going to create the similar question from each tutorial and then solve it yourself. You need to complete when? That is by this Wednesday 5 p.m. Where should you submit your work? Here. Through this website, tinyurl.com/mathematic2904. What we're going to see by this Wednesday, the submission included here. We have completed the first tutorial, the first column and the second column. Same goes to the second tutorial. Just complete the first and the second column, the tutorial and all the remaining tutorials. Okay, so many weeks ago you have gone through chapter 1 and then chapter 2. For these 2 weeks, today and next Tuesday, we're going to go through chapter 3. For today, we're going to focus the 3 subtopics for chapter 3, that is basic concepts, graph of functions, and operation of functions. So there are 2 important dates for this 3.1 to 2.3 chapters. That is today, we're going to have a short lecture, and then by this Thursday there will be a tutorial session. The details will be given at the last slide. We come to the first part of chapter 3, 3.1, basic concepts of function. What is a function? The definition of a function: it is an equation that has only one answer for output for every input. Sometimes people say that function is a relationship of one input producing one output. If we put into the graph perspective, a function is a line inside a graph with only one output. When we draw a graph, when we draw the line inside the graph, it will look not like this. This is not a function. No. Why? Because when we have one input here, it producing 2 outputs. This is not a function. This is an equation. Then the green color line is a function. Why? When we have one input, we are producing only one output. It doesn't matter from which point of the input. Let's say we go to the far right. This input, we're producing one that output. So if you forget about definition of a function, just remember the graph, the green color graph. For each input, there will be only one output. Just now when we go to the definition, there is some keywords such as output, input, and relationship. So what is the term used to represent output, relates, and input? The easiest one will be relates, because function is an equation. Equation has the symbol of equals. Let's look at the input. Input is the things that appear at the x-axis here. We call it input. It's obviously representing the x-axis elements, so we can use the x to represent it, x to represent it. Sometimes we call it domain. How to remember between the x-axis and the domain? It's easy. Domain bring us the term door. When we push the door, we are pushing it from where? Left to right. So next time when somebody say domain, remember door, and then remember left to right, and remember that is x-axis, and then remember it is input. Okay, let's go to the output. Output represented by the y-axis here. Sometimes we call it fx. Sometimes the same thing, we call it y only. Sometimes we call it codomain, and then sometimes we just call it range. It brings the same things, that is, it is the output. How can we remember is the codomain representing the output? Codomain give the first impression of condominium. So condominium is from up to down, so it looks like a y-axis, right? So it can trigger us to remember that codomain representing output. Okay, we will start our first tutorial, that is tutorial 5.1. Are you ready with your paper? If yes, then copy the question here. Define the domain of the function using the interval notation. There are two things we need to do. The first one, we want to define the domain. The domain door recalls us the inputs. And then the second thing is, we want to write our answer in form of interval notations. Let's settle the first thing, define the domain. In order to make the function valid, the denominator cannot be 0. So we can write the denominator cannot be 0 here. We factorize it. So we have two conditions. X cannot be 0 and x minus 1 cannot be 0, or x cannot be 0, x cannot be 1. So now we have the condition, so that this function is valid. How to write in form of interval notation? So in form of interval notation, so we can have any numbers from very far left, very negative, until close to 0. And then start close to 0 to the right hand side, and close to 1, and then a bit further than 1 until any positive real numbers there. So this is our answer here. Next, you see the second column. What you need to do with the second column is create a similar question and solve it here at the second column there. For example, you can write the function of fx equals to 999 divided by 4x squared minus 3. This is example, and then you solve it here at second column. Okay, take some time to do that. You can create quite a similar, very close question so that it's easy for you to solve. Or if you want to challenge yourself, you can DIY a difficult question, no problem. How about the third column here? Leave it blank first. Blank, okay? Leave it blank. Do nothing yet. Okay, do nothing yet. Let's move to the next subtitle here, graph of the functions. This is the function. Why? Because we have one input producing one output. One input producing one output. This is a function. It is part of the equation. But with one of the criteria is one input equals to one output. We can have many kind of functions here, like linear functions. The general representation is function equals to m's, the gradient times the x plus the b. B is the intercept at the y-axis there. We have the power functions, and then we have the root functions, the third one. When we look at each of the graph, we notice that it shares the same property with the above. What is it? One input producing one output. So these kind of equations are called function. Tutorial 5.2. So now the question is, can we merge two functions together and draw it at the same graph there? The answer is yes. We call that a compound function, as long as it meets the requirement of having one input producing one output. Let's sketch and find the function value of f when the input equals to 3 for the compound function here. So when we look at the compound function here, it's divided into two parts. The first part is valid when x is smaller than 2. The second part is valid when x is equals or greater than 2. So since the question asks us to sketch and find the function value of f3, so we start by sketching it. We need to define so-called the axis. One is fx, one is the x-axis here. The input have the so-called the cut off the critical point when x equals to 2. So we write fx equals to 1, f equals to 2, 3, add some numbers so that it looks a bit clearer here. And we put a dashed line here so that we differentiate the critical line there. When x is lesser than 2, the graph will look like x squared. So x squared, we will have this kind of curve. Oops, sorry. We will have this kind of curve here. Okay, up to here only. Okay. And it's good that we draw a small circle here to represent the end point of this curve doesn't touch 2. Okay, and the next one is when x equals to 2 or x is greater than 2, it is always negative 1. It is always negative 1 here. Okay, when x equals to 2 or above, it is always negative 1, like that. So we use the different color to represent how it looks like this one. So we'll have the, oops, sorry. So we have this kind of curve here, and then we have a circle, the blank circle here. Then after that, okay, it's a bit difficult. Then we have when function equals to negative 1. So next question is we want to find value of f3. The input is 3. When the function with the input 3, it fall under which section here? Here, right? X is greater than 2. 3 falls here. Here. So when f with the input equals to 3, from the graph, it is negative 1. Even from the equation itself, it is negative 1. Okay. Okay, next. DIY a similar question and solve. Okay, this is what you need to do. So you're going to DIY a similar question, and the question is here, and the solution is here. Okay. Still, the third box, the third column, you leave it blank first. Okay. We go to graph of the function. Sometimes you will hear somebody says that, oh, this is even function, and then some you can hear that people say, oh, this is an odd function. Here, what is the even function? What is odd function? Even function is a function when it meets this criteria. F with the input negative x will produce back the same function, fx. And then while the odd function is a function when we replace the input with a negative x, negative input, it's going to produce a negative function. Okay, a negative function. How can we remember that even function is this and then the odd function is that? Okay, we start from the even function. Even, we have the alphabet V. V for what? Vanish. Something vanish. Okay, when we put a negative here, okay, negative here, and then, oops, the negative disappear. See? The negative disappear. Okay, how can we remember that odd function is a function when f with negative input producing a negative function there? Look at odd itself. We have how many d's here? 2. D for deduct. D for deduct. Okay, this just help us to remember. Okay, so deduct, when the function come with a negative deduct, so-called deduct there, so we're going to produce also a deduct function here. So can that help you to remember what is even function and odd function? What it looks like as an even function. So normally we'll have this kind of the graph here, example. And the odd function, normally we have this kind of the curving graph there. Let's see at one here, tutorial 5.3. There are two questions here, which you need to determine whether the function is an even function or an odd function. Okay, remember the even function is something that vanish. Okay, vanish, and the odd function is 2D is deduct. Okay, deduct. Okay. Let's look at the first one. Fx equals to negative 3x squared plus 4. So in order to determine it is an even or odd function, so we replace the input with negative x, and then we look what will be the result. Negative 3 times negative x. Okay, a bit difficult. Oh, sorry. Okay, square plus 4. So it's producing negative 3, negative x squared, we get x squared plus 4. Okay, when we look at the original function here, oops, what do you see? It is an fx. So when we have a negative here and it vanish, so this is what? Even function. Okay, done. Let's look at B. So B, we are given the function. So what we need to do is we replace it with a negative x inside there. So equals to 2 negative x power of 3 minus 4 negative x. So when we expand it, what will we get? 2 negative x power of 3 plus 4x. So now we factorize it and see what happened. Negative, okay, 2x power of 3 minus 4x. Okay, when we look at the terms here, expression here, okay, it is the fx. So we have negative fx. When we look at the inputs with the negative, and it producing a negative input too, doesn't it sound like the deduct, right? So this is what kind of function? It is an odd function. Okay, done. Next, as usual, DIY a similar question, and then solve it here. So this is the question above, and then the solution at the bottom. How about the third box there? Leave it blank first. You're going to do that later on, very later. Okay, next 3.3, the last section for today. Operation of the functions here. When we are given two functions, and then these two functions are add up together, we call it sum function, and then it can easily represented by the summation of these two functions. Same goes to the difference function. We can just just minus those two functions. Product function is the multiple functions times. So these two functions times together. Quotient functions is the divide functions. We are given this function and then we write it this way, and remember that the denominator will always not 0, okay, or else this function is invalid. Okay, a bit different is the composite function here. Okay, composite function is when we have a function inside a function. So this is the way we write it. Yeah. This is the general idea about operation of the functions. We do a question here. It will give how to solve it. Okay, tutorial 5.4. Let fx, one of the function, okay, equals to 1 over x minus 3, and then we are given gx equals to x squared plus 5 here. So now we want to find the operation of those two functions in terms of the summation, in terms of the, what we call it already, the difference, and then what is the result from the product of the function, the quotient of the function, and the composite of those two functions. Okay, we will just do the last two, okay? The rest you try yourself. So, fg equals to fx divided by gx, with the condition that gx cannot be 0. Okay, gx cannot be 0, or else our function is invalid. Okay, fx is also 1 over x minus 3 divided by x squared plus 5. Okay, equals to 1 over x minus 3 times x squared plus 5 divided by 1. So we have x squared plus 5 divided by x minus 3. Remember that gx cannot be 0. Gx cannot be 0. X cannot be 3. Okay, this is our answer here. Okay, the next, is it fine I do it here? Because don't have space already. The function of f composite g equals to f gx here. Will equals to f, what is gx? Okay, gx is x squared plus 5. Okay, equals to 1 over x squared plus 5 minus 3, so equals to 1 over x squared plus 2. Remember that, you need to remember that the denominator cannot be 0. Okay, so means that x squared plus 2 cannot be 0. X squared cannot be negative 2. But luckily, because x squared always producing a positive value, which means that this how to say, this statement is not true. So we just no need to have so-called the defining the domain for this composite function here. So at the end, this is the answer for it. So now, okay, I forget. Okay, here, yeah. DIY the similar question and solve. Okay, you have the question here and then you solve it. It's up to you. You can create, you can construct a difficult question, or an easy question. It's up to you. Okay, another one is the inverse function. Inverse function is the reverse function or anti-function. How we write it? Okay, we write the inverse function using this term here, f minus 1 x. To find an inverse function, there are three major steps. First, we write the y equals to fx. Second, we solve the equation for the x in terms of y, and then we interchange x and y. So the resulting is y equals the inverse. Okay, now we want to sketch the graph of fx equals to the 3x squared is a quadratic equation minus 2. Then we want to find the inverse of the fx. So in order to draw the graph here, okay, one of the way is to identify what is the intercept value. It is minus 2. So we can just roughly draw the graph here. Okay, because x squared comes with a positive value here, so we are expecting there is a small curve here, a smiling curve. Okay, this is fx equals to x squared minus 2 here. Okay, now we want to find inverse of the x. The first step, okay, remember the first step, what we need to do, we want to write the function y equals to fx. Okay, what is fx? Equals to 3x squared minus 2. Now we want to make the x becoming so-called the subject. So y equals to 3x squared minus 2. Y plus 2 equals to 3x squared. Y plus 2 divided by 3 equals to x squared. So x equals to y plus 2 divided by 3. We insert it. Okay, step number 3. So we interchange between x and y. So just now x will become y. Y equals to, so y become x. As such, our inverse function equals to x plus 2 divided by 3. Remember to define the domain so that the function is valid. So for this one, it is a cert element inside there. It must be always a positive value. Means that x plus 2 divided by 3 will always be a positive or equals to 0. X plus 2 is greater than 3. So x is greater than 3 minus 2. X is greater than 1. So the domain is x must always greater or equals to 1, so that this inverse function is valid. Okay, now it's your turn. We're going to do a similar question and solve it. And leave it blank here. Oops. Oh, the answer is given. Tutorial 5.6. Okay, this is the last tutorial. Starting from the question, starting from 50 meter, the radius r of a circular oil spill increase at a rate of 0.5 meter per second. There's a oil spill. This is inside the ocean. Let's say this is ocean here. Okay. Initially, there is a 50 meter radius. This is like the first second. Then because the wave, and then there's a wind and causing the oil to increase the size with 0.5 meter per second. So after 2 seconds, we're going to see that it increases to 1 meter, the radius. Now we want to express the radius r as a function of time. Okay, the radius is expressed in terms of time. So it starts from 50 meter, and then what is the rate of the increment? It increases at 0.5 meter a second times t. Okay, done. A. Okay, for the B, the area A of a circular shape is given by A equals to pi r square. So we want to find the composite function of A composite r with the input t here. So we want to find what is the composite of ART. Okay, equals to A is pi r square. Now what is our r? Our new r is 50 plus 0.5t square. So when we expand it, we're going to get pi 50, oh, it's the same, sorry, t square. Okay, okay, done. B. And the C, how long it takes the area to be larger than 10,000 meters square? Means that ART is greater than 10,000 square. So can we do it here? So ART, we use the function to represent it is pi 50 plus 0.5t square is greater than 10,000. So later on, you expand it and then try to solve it, you're going to get that t is greater than 39 seconds. Mean that after 39 seconds and above, you're going to see the area as big as 10,000 or above. Okay, last tutorial, create your own application question and then solve it yourself. Okay, this is the same process, just leave the third box blank. We come to an end here. So today is Tuesday 28. Today is 28. Wednesday. Sorry, Tuesday. By this Wednesday 5 p.m. you already build your own question and solve it, and then you submit to which website? This website here. Okay, so for the third one, just leave it blank first. Okay, leave it blank first, blank. Okay, there are two important dates to remember before we end our class here. That is tomorrow before 5 p.m. Wednesday, remember to submit 6 pieces of the photo, and then by this Thursday here, there will be a tutorial session. Details will be given through eCampus and also through WhatsApp from your class rep. Okay, thank you class, and bye.